Problem number 2, we are given that the demand for a particular item is given by this demand function. Now look at the function. It's a quadratic, so it's a parabola. Coefficient's negative, so it opens downward, right? So it's a demand function. It's going to look like this. Now find the consumer surplus. So consumer surplus, all right, so first of all, I'm going to write that formula here. We have a defining integral for this. Consumer surplus is given as the integral from 0 to x sub e of, all right, we're going to have d of x, the demand function, minus the price, all that with respect to x. All right, so we're given the demand function. We want to find the consumer surplus. I wrote that formula. If the equilibrium price is $75, so right there, that $75, that's P sub E. Now, look at this integral and see if we have everything we need. We got the lower limit, of course. The upper limit, well, we don't have the upper limit. The upper limit is part of the equilibrium price, right? The equilibrium price goes like this. It's x sub E, P sub E. So we have one component. We have the P. We need to get the x. So x, we know, is the number of items demanded. So we know that that's what we're trying to find here. We're given the price is $75, and the price depends, let me see if I get this right, the price depends on the demand, which is a function of x. Now the price is 75, our demand function is 1950 minus 3x squared. All right, so we need to solve this equation here. So let's subtract that 1950, and if we do that, we're going to get negative 1875. That's equal to negative 3x squared. Let's divide by that negative 3. Okay, that gives us that x squared is 625. And if we take square roots, we get, okay, x is going to be plus or minus the square root of 625. So x is plus or minus 25. Again, we don't need the negative because x is the number of units of something produced. So x is 25. And that's really our x sub e, right? So now we've got what we need. Let's go back over here on the left and substitute in. So we're going to go from 0 to 25 of d, which is 1950 minus 3x squared minus p, but p is 75, dx. This will give us the integral from 0 to 25, and then 1950 minus that 75. Now, we just kind of did this, but this is going to be positive this time. 1875 minus 3x squared dx. Evaluate, anti-differentiate, 1875x minus 3x cubed over 3 from 0 to 25. Those 3's will cancel, right? So we're looking at this one. 1875 minus x cubed from 0 to 25. Well, I almost got that. Let me rewrite it. I forgot the x. 1875x minus x cubed from 0 to 25. All right, so now let's put in the upper limit. We're going to get 1875 times 25 minus 25 cubed minus, now here we go again. That lower limit is 0, and every term in here has an x in it, so we're going to get a bunch of zeros. So that term just goes to 0. And out of this, I am getting 31,250. All right, so our consumer surplus here is 31,250.